Welcome back. Today we're going to be looking at the ambiguous case of the sine rule. Before we get into that, I think it's really important that you understand when and in which situation you should use the sine rule. So if you think about pairs in a triangle, so how would I refer to a pair? A pair would be if I have the angle A and the side A. That would be a pair. If I had the side B and the angle B. Now, the situation where you need to be using the sine rule is that you've got a full pair. Okay, so if you look at this one, the full pair would be the angle 55 and the side 8.7. They're match. And you've got half a pair. So I want the red angle and I've got its partner, its corresponding side 10.2. So a full pair and half a pair. Then you need to use the sine rule. The cool thing about GeoGebra and this resource is you've got these things called sliders. So you can move them around and see what this is going to look like for different versions of the triangle. What we need to think about here is we don't know what this side is. We're going to set up the sine rule like this. So we can call this x, this is 10.2. This is 55, and this is 8.7. So we would have sine x divided by 10.2, that would be its partner, is equal to sine 55 divided by 8.7. If you're not sure what to put on top, if you should put on the sides on top or the angles on top, what you want to find, I always put what I want to find in this top left. I want to make sine x the subject. So I times by 10.2 times by sine 55 and divide that by 8.7. To go from sine x to angle x, I want to use shift. So I'll press shift sine and I'll type this fraction in. So 10.2 times by sine 55 divided by 8.7. So that will give me x at 73.81. So this was our triangle, but there was actually a second way to draw the triangle. So bear in mind the fixed things here are going to be the 10.2 and the angle 55. Now we've drawn 8.7 like that, but the second version could actually be like that. 8.7, if you think about this being the center of a circle and 8.7 being the radius of the circle, the second line here is set off at 55 degrees, but 8.7 could be here, which would make it an acute angle, which is the one we just found here, 73.8. But we could have also had this one being 8.7, which would make it an obtuse angle. Now, the thing is that if we think about it like that, so if we draw a circle, we've got our 10.2 here. We're setting this line off here at a 55-degree angle. You've got two options here. It could have been here, which would have been, so obviously this circle would have to have a radius of 8.7, or it could have been here. So there's two possibilities. Now the interesting thing is that we already have worked it out for the acute one. So this would be the acute one. This is the smaller one. So this is 73.8. Now this has to be an isosceles triangle because this length is the same as this length, which would mean that this option here would also be 73.8 if we're going to one decimal place. So the second possibility would be this triangle. So it could have been a triangle that looked like this, or it could have been a triangle that looked like this. Now to find this one here, the green one, all we have to do, because this is a straight line, is do 180 minus your first answer. So in this case, it would be 180 minus 73.8. I just type it into my calculator like that, minus ants, and you'll get the second answer, which would be 106.2. So there's two possible answers depending on how you construct your triangle. So you want to think of this as a line going off at 55 degrees. So these two things are fixed. Now, depending on, if you think about a circle with a radius of 8.7, you have two possible ways to form your triangle. Both of those triangles, this one has a 55-degree angle here, 10.2 and the other side being 8.7. Or we could do it like this. Again, we've got a 55-degree angle, 10.2 and 8.7. So if your angle looks obtuse, you need to do 180 minus your first answer to get it. If it doesn't specify, I would write down both answers. So that is the reason behind, or the rationale behind, the ambiguous case of the sine rule. Thank you for watching, and stick around. We're going to be looking at area of a triangle next. Bye for now.